Yes, so the next presentation is by Clàudia Abancó. She's from the Department of Mineralogy, Petrology and Applied Geology of the University of Barcelona. And she will present us how she monitored the debris flows in the Pyrenees. That looks quite interesting topic. Go ahead, Clàudia.
Hi, thank you. Just a minute. Okay, I think you should be seeing the screen now.
Yes, we can see your screen.
Okay, but in a presenter mode. Yeah.
Yes, that's right.
Okay, yeah, perfect. Thank you. So, well, first of all, yeah, I would like to thank to the organizers for the invitation in this very interesting workshop. So I am going to talk today about monitoring of debris flow in the Pyrenees, which is research that I started when I was doing my PhD at the UPC, the Technical University of Catalonia. And well, I've been following the collaboration with my colleagues there after the PhD. So even if I'm now based at the University of Barcelona, I keep collaborating with them in this research and the following projects after this. So the work I'm going to present today is mostly the work done by the whole group of the UPC. Okay, so mostly today I'm going to talk first about the debris flow hazard in the Pyrenees. And then I'm going to present some results, a general overview of the results gathered at the Rebaixader monitoring site, which is a debris flow monitoring site in the Pyrenees. So mostly I'm going to talk about how to detect torrential events and how to identify the triggering mechanisms. So as a very quick overview before starting with the specific results, I would like to talk about what's a debris flow. So, while debris flows are mass movements that are in between landslides and fluvial sediment transport that are characterized by having more than 50% of coarse material, well, coarse and fine material altogether, and high quantities of water too. So they behave as a fluid, as a viscous fluid that can achieve very, very high velocities when they run downhill, and they can have very high impact forces when they reach the bottom of the hills. So yeah, they are actually one of the most dangerous mass movements, especially in mountainous regions. So, well, we have heard a lot of debris flows in some mountain ranges like the Alps or the Himalayas, but at the beginning of the research, we were wondering if the reason why we haven't heard that much about debris flows in the Pyrenees is because maybe they don't happen, or they have lower magnitudes, or they have lower frequencies. So this was probably the main question at the beginning of this research project. However, if we go to the memories, in the Pyrenees, we have had some events that were quite relevant in terms of impact, and because, for example, this event occurred in 2008 in the border between Catalonia and Andorra, had a big impact because it was a torrential event that impacted to the border, the building border. So this was one of the memories of the events. And another torrential event that was really unfortunate in the 90s that was affecting a campsite in the Aragon part of the Pyrenees that unfortunately caused several casualties and a lot of damage. So there were memories of torrential events that could have been debris flows. So in 2009, when this project started, the main project, the first one, the debris sketch project, one of the main purposes was to try to gather information about these type of events in the Pyrenees. So we selected 4 main study areas that you can see in this figure. And we tried to collect based on published inventories in the news, in field surveys, based also on reports from stakeholders, evidences of debris flows and shallow landslides that had happened in the Pyrenees. So this came with some results that we were able to have a database of more than 2,000 events up to the moment. So it indicates that the hazard exists, and it's clear that there's some interest to study this. So one of the objectives of these projects was also to identify a place where we could install a monitoring site to gather more information about this phenomenon for the first time in an area with a Mediterranean climate influence. So from all this database of events happen, we wanted to select a torrent where there was a high frequency of torrential activity. So from all these, we selected the Rebecade site, among others. So we also installed other monitoring sites, but I'm going to talk about this one because it's the one providing the most interesting outcomes. So the Rebecade monitoring site is a place, a torrent located in a glacial valley that have like the initiation area of the events is a glacial till with unlimited sediment supply, as you will be able to see now in this video. So as you can see here, this is the upper part of the scarp of this torrent, where the slopes in this upper part are really high. This is a drone footage from the site. You can see also that then it continues to a torrent, more channelized area. And finally, there's the fan that you can see here at the end at the bottom of the valley, reaching to the river. So you can see there's lots of sediment and a steep slope. So in order to install some sensors to capture the activity in the torrent, we first wanted to install some meteorological sensors to identify the rainfalls that triggered the events. So we selected 2 different places to install sensors, meteorological sensors. And then another type of sensors that we wanted to install was soil moisture sensors and water potential sensors in order to see how the water infiltrates into this till, which is the mechanism, and to understand the mechanism of triggering of the event. So all these stations, let's call them stations, are sampling at 5 minutes, like constant sampling rate. On the other side, we also wanted to identify the characteristics of the dynamics of the event. So we installed another type of sensors, which were mostly geophones and flow height sensors, so ultrasonic devices and a radar, also with a video camera to cross-check the results of the sensors. So the flow height and the geophones are capturing at 5 minute sampling rate, but if there is an event, the sampling frequency increases to 1 Hertz, so 1 sample per second. How does it work? Well, the story is when there is an event, a torrential event that happens in this torrent, there is a vibration, which is captured by the geophones. So the geophones capture the signal, the vibration. Because of the very complex signal that the geophones were capturing and the limited sediment, the limited power that we have in the area, we decided to simplify the signal into a more simple signal, which is called impulses per second signal, which is basically we are counting one impulse every time that the signal exceeds a certain threshold of vibration. So with this transformation of the signal, we were able to capture actually the dynamics of different types of torrential events. So for example, and actually every one of them has a characteristic pattern. So for example, debris flows can be identified by a very high steep, like debris flow front, a very sharp increase of the vibration, and a gradual decrease of the vibration after the front, or debris flats, which are more similar to fluvial sediment transport, are characterized by a gradual increase of the vibration, or rockfalls, which also happen in the area, which are mostly an impact, one single or few impulses. So as you can see now in this video, that we used all these videos also to cross-check the information of the geophones. You can see here approaching a debris flow front. Here you see an ultrasonic device which is measuring the flow height of this flow. This was the debris flow front, which was captured by the ultrasonic device, and we could actually identify the flow height, and therefore we were able to calculate the peak discharge and the volume of this event. So thanks to all this information coming from the sensors, we have been able to identify until 2020 14 debris flows, 23 debris flats in the torrent, and we have also been able, using the sensors and some geomorphologic observations, to calculate the estimation of the volume of the events. And so we could come up with a correlation between the magnitude and the frequency of the events, knowing now that we can actually expect probably up to 2 debris flows per year in this torrent and several debris flats, which was quite interesting. Then we wanted also to analyze how these events happen, and that's why we installed the meteorological and infiltration stations. So the type of analysis that we did here was we analyzed the rainfalls that were triggering debris flows and debris floods, and other rainfalls that didn't trigger events, trying to come up with a correlation with a threshold that could indicate which would be the intensity and duration that if this is exceeded, there's going to happen a debris flow or a debris flood, which is probably one of the most interesting outcomes in terms of early warning systems that we could look for. As you can see here in the left, there we could calculate some thresholds, but these thresholds are not exactly like they don't perform so well, no, because there's many rainfalls that exceeded the thresholds, but they didn't trigger any event. So then, trying to understand why this happened, we looked at the chronology or the timing of the events, no, the debris flows and debris floods, and also the general rainfalls. You could see here that even if the rainfalls start early in the year, so the rainfalls in the torrent happen between April and July mostly, the events only happen normally in June, July. So there is a shift in between the peak, the most common time for rainfalls and the most common times for debris flows and debris floods happening. Why does this happen? Well, the story to understand this, we tried, because the idea is probably they need some soil moisture to be in the soil, some water to be already in the soil to trigger an event. So that's why then we analyzed the data from the infiltration station, so the soil moisture and water potential. And actually, well, you can see here that this is one of the debris flows. happening in July 17th, 2013. And if this indicates, the dashed lines indicates the time of the event, while the rainfall starts a bit earlier, and you can see actually how there was already a certain water in the soil. This is the volumetric water content in the soil. But when the rainfall occurs, this increases sharply, and then the event occurs. So the idea then was like, can we improve these thresholds, rainfall thresholds, by introducing some of this data, the volumetric water content data? Well, this is what we started, we tried to do, and this is actually still an ongoing research, which is having some very promising results in terms of analyzing the initial volumetric water content and the increase of volumetric water content due to the rainfall that triggers the event. So by comparing the initial volumetric water content and the intensity of the rainfall, we would like to come up with a threshold that could indicate actually that you need a certain volumetric water content and a certain intensity of rainfall to trigger an event. So just to conclude, well, debris flows are actually a real hazard in the Pyrenees. We have proved that now already. The ground vibration is a useful tool to detect and characterize torrential events. The information on the dynamics of the events can really be extracted from the combination of these geophones, the video camera, and the flood height sensors, which is something really interesting also to be applied in other areas, also with early warning and alarm purposes. Torrential events in the Rochede, this special torrent, mostly happen in summer after spring rainfalls. So we need these spring rainfalls to happen probably to occur the events. And finally, well, the combination of soil moisture and rainfalls show very interesting results for early warning. And well, thanks for the attention. These are some pictures of the group, of all the group of people involved in this research, and more missing here too. But yeah, you can follow updates of this type of research in 2 websites of these 2 projects, all about landslides and soil erosion in the Pyrenees. Thank you so much. I'm going to stop sharing now.
Thank you, Claudia, for your nice presentation and for being in time.
Yes, yeah, I agree. Claudia, so we may ask if there is any question from the audience. Not yet. Well, I have one question about, actually you did not really mention the type of material. If you have mapped the catchments or subcatchments which are prone to such debris flows, did you find some connection with the type of material?
Well, so for this specific catchment, we already have a very detailed analysis of the type of material, like granulometry curves and all these type of geotechnical parameters, resistance, etc. Not for all the 2,200 catchments that we have identified as potential or that they had events. But yeah, well, certainly you need, and this is something that we are also trying to do, no? To see which kind of materials can be probably more susceptible to have this type of events, or if there is anything else like, I don't know, slope, other geomorphologic parameters that could indicate more susceptibility to these events to happen.
Yeah. Okay. Well, usually, the percentage of fine sediments, which will increase the density of the flow, will allow these debris flows.
Yeah.
There is a question on the chat. Anna Novak, she says, "Great talk and great work." I fully agree. How do you receive the signal from the geophone? And do you have a small seismograph? That's a question.
Yeah, well, that's interesting. We had two different systems to gather information from the geophones. One was actually a seismograph, well, like a seismic recording unit, very similar to what it would be used for earthquakes or yeah, some kind of seismic analysis. But this was installed for a specific time. But then, as I mentioned, we developed like a transformation, well, which was developed in Switzerland, but we adapted for our geophones to transform the signal to make it a bit simpler. So it's just a normal data logger that is connected to a geophones by a signal transformation in between. It's an electronic board that transforms the signal.
Okay. Well, that's interesting.